Hello again, grade 11s. This is part 2 of limiting reagents and percent yield. So we have gone over a stoichiometry problem, looked at two ways to solve it. Those are the fact label method here and proportion method here. Okay. Then we talked about limiting reagents and looked at a practical example to figure out which one will be our limiting reagents and which one will be our excess reagent. We did an example that exists in a 1-to-1 ratio. To figure out that one of them is our limiting reagents, pretty simple here, just one step, find moles and convert. Then we end it here. So this is where you see a more typical example. We have 15.8 grams of aluminum and 55.6 grams of bromine. You know that this is a limiting reagent question and not your average stoichiometry question because you're given a mass of both reactants. So it's not going to be your straightforward stoichiometry problem. Your stoichiometry problem will begin at part B. Let's take care of part A first. Which one is limiting? Which one is going to define how much product is going to be made? So as always, when you don't know what to do, or even if you do, always figure out the number of moles. So let's do that. Find moles of each. Here we have aluminum divided by molar mass, bromine divided by its molar mass, and we get these values for moles of each. Okay, I'm going to move on to the next slide. I'm going to keep these values so you can see them. And we have these values still up here in black. So now the limiting reagent problem, part that's new for this limiting reagent problem, begins here. We now have to figure out which one of these is going to be limiting and which one is going to be the excess. The number of moles for either are different, and usually the one that is greatest, or always one that is greatest or least, is not going to tell you exactly which one is limiting. So you have to create a hypothetical situation, a test situation. So let's do that. Let's pick one. Okay, we're going to pick, in this case, we picked aluminum. And we're going to test then to see aluminum, in this case, how much bromine in moles. So how many moles of bromine do we need given the amount of aluminum we have? So we're going to look at then mole ratios from the balanced equation to figure out how many moles of bromine we would need given the amount of aluminum. So that's the hypothetical situation. Given amount of aluminum, how much bromine do we need? We know we know how much we have. We have that much. But hypothetically, how much would you need given this amount according to this mole ratio? So mole of aluminum cancels out, and we're left with 0.879 moles of bromine. Now we can compare. Do we have 0.879 moles of bromine? No, we don't have enough. Because we don't have enough bromine, therefore this is going to be our limiting reagent. We need more than what we have, so what will limit us then is bromine. Right? We're comparing these two, and this is the reasoning again, therefore bromine is our limiting reagent. Okay, I said we could have picked any of these moles to test the other. I picked aluminum, tested how much bromine we have. I could have done the opposite. I could have picked bromine to test how much aluminum we need. So given the amount of bromine that we have, you don't have to do both, just choose one. You could have ended here and that would have answered part A. Or if you chose the opposite, if you chose aluminum to be tested with a given amount of bromine, you would have ended up with the same results. Not the same mole answer, but the same results. So this tells you that with this amount of bromine, you need that much aluminum. Do we have that much aluminum? Look, we do. We actually have more than we need. Therefore, this is our excess, and that has to be our limiting reagent, right? You end up with the same conclusion that bromine is our limiting reagent and aluminum is excess. So part A is done. Part B now becomes a stoichiometry problem. We know that the limiting reagent and only limiting reagent will be able to tell us how much product is made. That defines how much product we can make. So we can ignore the excess agent in this question, and it now becomes a hopefully straightforward stoichiometry problem. So how many moles of product, what you have, what you need here, times mole ratio with mole at the bottom of bromine, that's 3 from the balanced reaction. What you need at the top, aluminum bromide, we have 2 from the balanced reaction. Cancel out, cancel out. That times 2 divided by 3 gives us that many moles of aluminum bromide. right? The question's not asking just for moles, it's asking you for mass. You have to multiply by molar mass. Mole cancels out. You know this came from your periodic table, and we get 61.9 grams. With 3 sig figs rounded, that's our answer. That is it for limiting reagents. It isn't too difficult once you get your head around it, but you do need to try and practice first. Okay, now next topic, theoretical versus actual yield. Theoretical is what we calculate. So doing the math, doing the stoichiometry, this is what we should theoretically get given 100% yield. That isn't always the case, though. What you actually get in a lab is your actual value. So that's where percent yield comes in. Again, your theoretical is predicted by how much you're able to produce in grams, usually based off of stoichiometry. Okay, your actual yield again is how much you're actually able to collect in an experiment. To figure out percent yield, all you do is you take your actual yield, you divide that by your theoretical yield, and you multiply that by 100. So essentially it's like figuring out your mark in a test. What could you have gotten? So out of 10 marks, let's say you could have gotten 10 marks, but what did you actually get? Let's say you got 8, so that would be 80%, right? So what you actually got divided by the total amount of product predicted, calculated, is your percent yield, right? Then that's it. Your homework, practice it. These are good questions. I have some extra practice online. I'll post a video or two that will go over the more challenging questions, but ask me questions so I can focus on those. Hopefully this helped.